Okay, so this is the first example we're going to do on a series parallel circuit. This is example 1. And what we're going to attempt to do is to calculate the supply current, which is the current here, I, which will come round, hit that junction there and split into two currents, which we'll call I1 and I2. Try to calculate these currents. And we're also going to try to calculate the voltages in that circuit as well. So the voltage will split across those R1 and your RP, if you like. You'll have a voltage across here, V1, and a voltage across here, VP. And because R2 and R3 are in parallel, the voltage across each of them will be the same. The first thing I think it'd be a good idea to do would be to draw an equivalent circuit for this. So your equivalent circuit for this would be a circuit with two series resistors, R1 and RP. Supply in the same way round. Still 20 volts for this. 10 ohms here. Current I here would be the same as the current I here. So when you calculate this, you've calculated this. The voltage across R1, V1, the same as this V1. And the voltage across here, VP, would be the same as this VP. So to start off, we have one unknown in there, RP. So RP is for a parallel resistance for the 15 and the 12. So the way you'd work it out, 1 over RP is 1 over 15 plus 1 over 12. So on your calculator, you do 15, 1 over, plus 12, 1 over, equals 1 over that answer, equals, and then go into a decimal. So my RP value is 6.667. And that's it to 4 significant figures. So 6.667. So I'm going to add this into my drawing. Add it in here, 6.667. And then I'm going to use this equivalent circuit to work out the value of I, V1 and VP. So to get all the current, use all the voltage and all the resistance. So I haven't worked out my total resistance yet. And my total resistance, my 10 and my 6.667 are in series. So I'm going to add R1 plus RP. So I'm going to add 10 and 6.667, getting me 16.667 ohms. Then to get I equals V over R, if you remember your triangle. I'll pop the triangle in here as well. So if you're looking for I, you cover over I and it's V divided by R. V, the supply voltage, we're working in this circuit here. And R is your total resistance, 16.667. Now you can use this formula for a whole circuit or for one component within a circuit. So I'll clear that down. 20 divided by 16.667 gets me 1.20 when I round that to 4 significant figures. And that's amps. So that 1.20 is the value for the current here. Is the value for the current here. It's the same, these circuits are equivalent. Then to get V1, use my formula again. I times R1 1.20 times 10 gets me 12 volts. Then thinking about this, if this is 12 volts here from our V1, which will be 12 volts here as well, then 12 out of that 20, you would think this one's going to be 8. So we'll just double check that, because 12 and 8 gives you 20. Vp so 1.20, same current again, times your Vp, which you worked out at this stage here. Standard to decimal. So that is to 4 significant figures, that's 8 volts. Which works out fine, because I would think that if one's 12, that one has to be 8. That's 8 volts there, 8 volts there. So 8 volts across R2, 8 volts across R3. So this triangle works for the whole circuit or for one component. So I'm going to use this on one component now. I'm going to use it on R2. And on R2, I1 equals Vp, that's the voltage across R2, divided by the resistance of R2. So just on this one component. Vp I've got here, 8. R2 is on my circuit diagram, that's 15. 8 divided by 15. When you see that wee dot, it means a repeater. .533 amps. I'm going to do the same for I2. So I2 only exists between R3, and the voltage across where that I2 goes is that 8 volts. So again, it's going to be Vp over R3. 8 divided by 12. And 8 divided by 12, 2/3, so 0.6667. And you know that these two, when you add them together, the current coming into here is 1.2 amps, so that should split into 1.2 amps between these two. So if I add my 0.5333 and my 0.6667, I get 1.2, which is my supply current there. So that all checks out fine. And that's my first example complete.